Throughout the universe, there are roughly 2 trillion galaxies. Our own Milky Way is packed with hundreds of billions of stars, and the number of planets out there is practically infinite. Because we live on this specific rock, we naturally project our earthly biases onto the rest of space. We constantly scan the dark for the familiar comfort of blue oceans and white clouds. So when we spot a distant bright blue sphere through a telescope, our brains immediately jump to a comforting conclusion. We imagine calm waters, feeling gentle breezes, and a perfectly safe environment. From far away, Kepler 7b looks exactly like that kind of paradise. Its vibrant blue color mimics everything we associate with a welcoming, safe haven. But any space traveler who actually trusted that earthly logic and plotted a course for those friendly skies would be flying into immediate, certain doom. In deep space, our human intuition becomes a fatal liability. A welcoming appearance is often a mask for the most hostile environments in existence. Plunging beneath those inviting blue clouds reveals a nightmare. The baseline atmospheric temperature sits at a thoroughly lethal threshold. This chart illustrates atmospheric velocity. Earth's Category 5 hurricanes top out around 160 miles per hour, but Kepler 7b's winds reach 5,400 miles per hour, 7 times the speed of sound. This kinetic force would instantly shatter any visiting spacecraft. Because of the extreme 500-degree heat, this planet does not rain liquid water. It actually rains molten glass. Those supersonic winds whip the glowing glass into horizontal projectiles, capable of flaying any object or traveler in their path. That beautiful bright blue color you see from space has nothing to do with water. It is simply the optical illusion created by a supersonic atmospheric blender, a harsh reminder that earthly chemistry rarely applies out here. Kepler 7b is only one terrifying example of how the cosmos routinely defies our assumptions about how planets operate. Take a world like Kepler 186f. Astronomers often call it Earth's cousin because it sits directly in its star system's habitable zone, meaning life could theoretically survive on the surface. This diagram shows a crucial difference in the light hitting that surface. Because Kepler 186f orbits a cooler, redder star, the heavy concentration of red wavelengths forces plants to evolve a different way of processing energy. Instead of the familiar green canopies we see outside our windows, an alien forest here would be entirely dominated by striking bright crimson leaves and thick red grass. Then there are rogue planets. These solitary worlds lack a star entirely, drifting endlessly through the freezing, pitch-black void. Without a sun to warm their surfaces, their cooling cores generate entirely different weather systems, producing violent storms where heavy bands of molten iron plummet through the absolute darkness. Whether it's a crimson-lit forest, a thunderstorm of liquid iron, or a supersonic glass hurricane, the universe operates on a scale entirely alien to us. Every one of these extreme numbers and bizarre environments represents a physical reality in our current universe. The glass storms of Kepler 7b and the molten iron rains of rogue planets are occurring at this very moment, hidden behind the quiet beauty of the night sky. Against that backdrop of cosmic violence, humanity is really just a fragile collective of primates, surviving together on a single, silent blue sphere. For as long as we've been here, we've looked up and hoped to find other worlds exactly like ours, searching for friendly neighbors in the dark. But that quiet hope stands in stark contrast to the sheer, undeniable hostility swirling violently through the rest of the galaxy. While there may be other life out there somewhere in the infinite expanse, realizing what is actually happening on a world like Kepler 7b makes one thing clear. Having liquid water fall from a calm sky is the ultimate stroke of luck.